So in this video, we'll describe the zeroth and the first laws of thermodynamics. So i-define natin sila, tapos magkakaroon tayo ng mga parameters na i-describe din natin as they come up while we are discussing these laws. Okay, so mag-start muna tayo dito sa zeroth law of thermodynamics. So the zeroth law describes a thermal equilibrium situation. So given three bodies, system 1, 2, and 3, okay, system 1 in this diagram is in contact with system 3. System 2 is in contact with system 3. So, ibig sabihin, yung contact na to, ang ibig sabihin lang naman yan ay nagkakaroon sila ng heat transfer or possible yung heat transfer from system 1 to system 3 and vice versa. Ganon din sa system 2 and system 3. Pero hindi possible yung heat transfer between system 1 and system 2 kasi hindi sila directly in contact. Okay? Nagkakaroon lang sila ng contact through this particular motion or direction of heat. Pero in this situation, we'll describe the system as in thermal equilibrium with each other. Okay? So at thermal equilibrium, if the temperature of system number 1 is equal to the temperature of system number 3, and the temperature of system number 2 is equal to the temperature of system number 3, okay? Therefore, the temperature of system number 1 is equal to the temperature of system number 2. Okay? So that's temperature. Pero kapag binroaden natin yung concept, okay, if system 1 is in thermal equilibrium with system 3, okay, and if system 2 is in thermal equilibrium with system 3, therefore system 1 is in thermal equilibrium with system 2. Okay, yun yung ibig sabihin ng zeroth law of thermodynamics. So pwede nating gamitin yung any of this system to describe the thermal equilibrium or the temperature of the other systems. Halimbawa, pwede natin gamitin thermometer or measurement source, si system number 1, para ma-predict natin yung temperature ni system 3 at ni system 2. All we need to do is to make system 1 in contact with any of these systems. Pwede natin siyang gawing in contact with system 2 or in system 3. Tapos, mapipredict na natin yung kanilang energy through their temperature. Okay? So, what particular device has this particular purpose? So, we have thermometer. Okay? Thermometers work on this particular assumption. Okay? Ito yung kanyang purpose. Kumbaga, nagiging valid yung thermometer as a measuring device because of the zeroth law of thermodynamics. Kasi, if the thermometer describes a certain temperature at thermal equilibrium, okay, and the surroundings B is at thermal equilibrium with the system, which is A, na nasa loob ng B, okay, all we need to do is put the thermometer inside para magkaroon din ng thermal equilibrium si B dun sa thermometer. So, kung ano man yung magiging temperature ng thermometer, yun na rin yung magiging temperature ni A. Okay? So, let's review the premise of this system. A is a closed system, so hindi nagkakaroon ng matter transport in and out of system A. B is in thermal equilibrium with A, so pareho sila ng temperature, and the thermometer is in thermal equilibrium with B. So kung in thermal equilibrium yung thermometer tsaka yung B, we can just view the temperature reading dun sa thermometer, tapos mame-measure na natin yung temperature ni A. So that's how amazing this device is, kahit ganun man siya simple, because it is actually devised based on the zeroth law of thermodynamics. Okay? So, how do you change a state, okay, of your system? So, paano mo napapalitan yung system from its initial state, tapos mapapalitan mo siya to the final state? Okay? Paano mo mapaperform yung change na yun? Okay? So, what you want to do for gases specifically is to change the pressure, temperature, volume, number of moles. Either one of them will do, or any two of them, or three of them. Pwedeng lahat. Okay? But you cannot literally change them. So, pressure, temperature, and volume specifically are not some things that you can just give or take. Okay? So, hindi mo po pwedeng bigyan ng 1 atmosphere ang isang gas para maging 2 atmosphere siya. Okay? Hindi siya literally ganon. Okay? Pressure is a state function that is a result of either the input or output of this particular path functions. Okay? So, how do you increase or decrease the pressure? So, syempre, kapag gusto mong mag-decrease ng pressure, babawasan mo yung work, or you let the system do work. Kung gusto mo namang increase yung pressure, you will add work. So, you will perform work into the system. Okay? That's how you literally do work. Okay? Work is something that you do to the system. Unlike pressure or temperature, you cannot add 1 Kelvin sa system. Okay? You add temperature or you increase the temperature of the system by putting heat into the system. Okay? You put heat or you remove heat from the system. That's how you increase or decrease temperature. Okay? So, ganun din sa volume. So, increase it. If you want to increase the volume, you need to make the system do work to the surroundings. So, negative yung W, mag-increase yung iyong volume. Tapos, kapag gusto mo nang bawasan yung volume, positive work. So, you will perform work into the system. Okay? So, that's how states and path-dependent functions interact with each other. So, you will perform different path-dependent functions or energies para mabago mo yung state functions ng system. So, in terms of the number of moles, actually, number of moles is literally a state function. Pero, pwede mo siyang gawin directly. You can actually add or remove amount sa system. Pwede mong bawasan or dagdagan yung amount ng material sa system na yun. So, that is Zeroth law of thermodynamics. Okay? So, for the first law of thermodynamics, this describes how you can change a particular state of the system. Okay? So, para mabago mo, for example, yung delta U or yung internal energy ng system, you can either add or remove heat, which is a temperature-dependent function, or you can add or you can perform work against the system. Okay? Kung pwede mag-add ka ng work or remove ka ng work, or you let the system do the work to the surroundings. Parang negative yung W. So, work is a function of volume. Heat is a function of temperature. So, this is dV. Okay? And this is dt. So, since delta U is Q plus W, delta U is also a function of the volume and the temperature. So, you can actually express U as a state function that is a function of temperature and volume. So, pwede mong isulat yung total derivative niya like this. So, du is equal to the partial derivative of u with respect to the temperature at constant volume times the change in the temperature plus the partial derivative of u with respect to the volume at constant temperature times dv. You add this particular term kung open yung system mo or kung may nangyayaring chemical reactions dun sa system at constant volume and temperature. Okay? So, change in the number of moles, change the internal energy. Pero kung closed yung system mo at wala namang reaction na nangyayari, you can disregard this particular term. Okay? Pwede may cancel yan. Dito lang sa dalawa. Okay? So, for the differential form of the first law, du is equal to dq plus dw. So, dq and dw are path functions. Usually, nilalagyan natin siya ng parang bar na ganyan para ma-differentiate natin na yung iyong Q and W, yung changes nila, pwede mong ma-perform at different manners. Okay? You can perform changes in Q at constant pressure or at constant volume. You can do work, di ba? It's either compression or expansion or pressure volume or volume pressure muna, di ba? May manner tayo kung paano ginagawa yung work. Okay? However, du is just a state function. So, dw is equal to negative p dv. Okay? So, depende how many steps mo ginawa yung work. Okay? Again, it shows how work is a path function. So, at constant volume, work is 0 kasi dv is equal to 0 since constant volume. So, delta u or du is equal to dqv. It means that heat at constant volume is the internal energy. So, the Q that is supplied or removed from the system at constant volume, that is the du or the internal energy of your system. Okay? Also, if you differentiate U with respect to temperature at constant volume, you will get CV. So, CV is the heat capacity at constant volume. So, this is the amount of heat that you need to supply to the system for it to change its temperature by 1 unit. Okay? So, kumbaga, kung gusto mong erase yung temperature, for example, from 25 degrees Celsius to 26 degrees Celsius, you have to input some amount of heat. Okay, so for water, to be able to raise the temperature of water from 25 degrees Celsius to 26 degrees Celsius, you need 4.184 joules, okay, per mole of water. Syempre, 1 mole lang dapat yung water na yon. You need to input 4.18 joules. So, kung 2 moles yung water mo dun sa system, edi 4.184 times 2. Okay? So doubling the amount of water doubles the amount of energy required to raise the temperature of the system. So 4.184 joules per mole per degrees Celsius. So that is the heat capacity of water at constant volume or at constant pressure. So actually, ang constant pressure and constant volume heat capacities ng water ay pareho lang since water is it's not a gas, it's a liquid. Okay? So it's not very significant. Kumbaga. Okay? So that is the zeroth and the first law definitions. So sa next video na lang natin i-discuss yung mga consequences ng zeroth and first law of thermodynamics. Okay? So see you next video.